Hey everyone, thank you so much for joining today's Hoodie Community Sing for the month of May. We'll just give a couple more minutes for people to join and then we'll get started with our today's agenda. Let us know where you're joining from and if you're implementing Hoodie in your organization and if you have any questions around it. So we'll be monitoring the LinkedIn chat as we continue with the session and we'll take it from there. So we'll just give a couple more minutes and then we'll get started from there. All right, I can see people joining in. Uh, so just a reminder for people joining in, we will have this community sing from Zupee today, and post that we will also have some time for Q&A as part of the session. But also feel free to ask any questions in the LinkedIn Live, and we can take the chats asynchronously as well after the session. All right. All right, I think we're good to get started with the session. So I hope the screen is able to be seen. All right. So welcome to the Hoodie Community Sing for the May month. If you're new here, the Community Sing allows community users and developers to meet, interact, and exchange ideas on Apache Hudi and how it is implemented in various organizations for their data lake or data lakehouse architecture. So today we have yet another interesting presentation from Zupee. Zupee is an online gaming company in India with a kind of a leading market share in casual and board games segment. And during this presentation, our speaker, whom I will introduce in a few minutes, will discuss about Zupee's data lake architecture and the requirements for real-time data ingestion using Apache Hudi. So before we go into the actual presentation, we'll be quickly going over the community stats and updates from the community and what has happened in the past month. And then we will start our session from Zupee, and then we'll end with a quick Q&A session. So like I said, since the session is live on LinkedIn, feel free to post your questions in this chat as well, and then we can take it from there. All right, so let's jump into the community stats. So for the month of April to May last month, we have had over like 139 PRs that are being worked. So a lot has been brewing on the Hudi project side. There is a great momentum there. We had 29 developers who contributed to these PRs, which is really good to see the diversity there. And we also are, close to 33 issues during this time. And there are a lot of new PRs being worked on in the next phase as well. In terms of the community growth numbers, we have over 4,200 users on Slack today. Slack is a great place for Hudi users to bring up any discussions, issues while implementing Hudi, knowledge guides, and there are PMCs to chat there for issues. So I'll share the link in the next slide for you to join the Slack in case you are not part of the group. On GitHub side, we now have more than 5,100 stars, so really good momentum in there. And of course, I mentioned about the 29 contributors in the last month that contributed to all these changes in the PRs. We also have a major release that is upcoming, which is 0.15.0. The second release candidate is now out for the voting. So once it is done, we'll be going ahead with the release for the next 0.15.1. And we also have a new RFC 77 to support secondary indexes with Hudi. We are definitely growing, and if you are or aren't already following us, give us a follow on LinkedIn and Twitter. We really create and curate content stuff. It's a really good idea to be there to get updated on all the stats and updates that's happening in the Hudi world. You can scan the QR code that's present in this particular site to join the community if you're not already present. So with that, let's welcome Amarjeet Pasrija, who is a senior data engineer at Zupee. And I'm going to add it to stage. Hey, Amarjeet,
Hey,
welcome
hi,
to the
Dipankar.
Community Sync.
Hey, hi, Dipankar. Thanks for introducing me.
Yeah, and I'm going to like let you like take it over from here. So feel free to like take the presentation from here.
Thank you so much. Hi everyone. I'm Amarjeet saying it is fantastic to be here with you all. So I'm a senior data at Zupee. My most part of my day-to-day job is to create a powerful data platform that simplify data processes, analysis. It's like finding a treasure, but with algorithm and coffees, of course. So let's dive into the what we are going to be exploring today. So the today context is more introduction about Zupee, what we're doing at Zupee, and all the stuff, how the data platform architecture looks like for the Zupee, and the what how we are ingesting with the next gen data platforms in Zupee, and a little bit about Hudi data stream, how we are leveraging it, and how we are leveraging it the mostly for the cost efficient way and the faster to merge and better to carry it. Okay, so let's first deep dive into the about Zupee. So Zupee is India's largest skill-based Ludo platform. So it was early formed on 2018 with a vision of bringing moment of joy to the users and meaningful entertainment. Zupee is the first platform to introduce skill element to culturally relevant game like Ludo. Zupee was revived the joy of traditional Indian game like Ludo, and there are many others. The goal is to make gaming not only fun but also enhance a player's skill. So, at Zupee, data plays a very crucial role in everything we do, from understanding user behavior to optimizing our services. Data is the core of our decision making process. Our architecture is designed to efficiently process, analyze data, ensure that we can exactly value insights in a timely manner. So let's dive deep into the core data platform architecture, which is designed to handle the complex data needed in Zupee efficiently. So first, we start with the various data sources which we have, which feeds into our platform. They can be anything from user information to user interactions to transaction logs to third-party data providers. So next, the first layer what we have is a data lake layer, which is structured into the three sections. First is a landing zone, which contains where the raw data first arrive. It's like a receiving a dock where all the incoming data is stored in an original format. Then we have exploration zone. Here the data is cleaned or made ready to explore. Analysts and data scientists use the layer to understand the data and derive insights out of it. The next layer, which comes is the analytical zone. Mostly, this is a processed data which is advanced and used for all analytical purposes, for optimized query purposes and retrieval. It can store OLAPs, facts, and dimension, and we can say a one big table also. Next, in the middle, we uh, yeah, in the middle layer we have a metastore and API layer. The A layer act as a brain for our data platform, engaging metadata and providing API for data access and integration. We have we also have the orchestration and framework layer. The, this includes tools like Airflow for scheduling and managing workflow, as well as in-out build tools and frameworks to handle ML operations, data ingestion, and data computation. Of course, Hudi Delta Stream for ingesting the data. These tools ensure our data can run smoothly and efficiently. Above this, we have a compute layer, mostly which includes Apache Spark for large-scale data processing, Athena for interactive query analytics purposes, and Trino for distributed queries. The next, which comes is a interesting part, is the real-time data needs, which for that we are using Apache Flink, the powerful stream platform for frameworks to store the features stored, enabling real-time model predictions. It is essentially for application that require immediate insights and action. Finally, top of the is the serving layer. This includes the real-time dashboards which are powered by Apache Flink. Uh, Analytical dashboards which are mostly powered by Athena and Trinos. Then we have some Jupyter query books which is used for ad hoc purposes and machine learning team or data scientists are using for querying the data lake layer. Now let's move ahead and explore the next gen data ingestion, how we are leveraging the workflow based ingestion to enhance the performance of our reliability and data pipeline. So the generic workflow based ingestion or pipeline utilize basically a workflow based ingestion to ensure smooth integrations and scalability. This approach allows us to handle various data sources and ingestions take efficiently, providing a robust framework that can grow with our need. So we have a centralized configurations details. So centralized configuration details for ingestion jobs that centrally managed using YAML files mostly, which promote consistency and easy for updation. The centralized configuration system is hosted on mostly on Amazon EMR, enhancing control and simplify management and ensuring uniformity across all data ingestion. Now the granularity part, granular control. So when we are giving a YAML a centralized location, but also we are getting a carrier control over the particular on the table level. For that, we have a YAML-based configuration allows for granular control job level. This means that each job can be tailored to specific needs and requirement without affecting the overall system, whether suggesting the parameter of particular data source or optimizing performance of a specific job. Like if we want to increase the memory of a Spark job to adding new configuration, we can easily do on the job level basis. Then the fourth part which comes is the automation. Our systems automatically generates the Spark commands based on the YAML configuration, reduce the manual intervention and minimize errors, which accelerates the development process for us. To give a clear picture about it, how this workflow works, let's deep dive into it. So here, what happens? The generic job when reads the database YAML, which contains the specific job information and tenant level configurations. So we have multi-tenant sets of generic pipeline. So if we can change with a different version of Spark, with different version of Hudi Delta streams, Hudi different versions of Scala. So we can handle it with the tenant level. And then we have a single trigger uh, which triggers the config based for each pipeline. These generic jobs then create a Spark configurations and all those Spark submit command with the Hudi Delta stream for the Hudi and generate a Spark submit command first. Or this configuration then is submit using Livy either to the to EMR or using a EMR steps. Throughout the process, we also tracks the Livy session EMR step for monitoring and doubling purposes. This workflow-based approach streamline our data ingestion process and ensure is both scalable and reliable. By automating critical steps and maintaining central control, we can handle large volume of data efficiently and adopt of changing requirement with ease. Now let's deep dive into the how Spark we are using Hudi data stream with Spark. So let me first give you about what is Hudi data stream and framework and how we are utilizing it. So Hudi Delta SP is a utility, or you can say a framework, which work on the mechanism of checkpointing based ingestion, even from various different sources like from distributed file system, which is stored in S3 or your GCP store, your Azure store, or then there is a Kafka source or any JDBC store like directly calling from MySQL or Mongo. So with checkpoint-based mechanism, what it shows that consistency and availability to resume from the last checkpoint in case of interruption. Next is one of the standard features of Kubernetes stream is to perform easy backfill based on checkpoints. This allows us to reprocess historical data efficiently and having to digest the entire data set from scratch, having saving both time and resources. Then one of the major things which is the syncing of data catalog. So Hudi data stream that provide a automatically syncing to the catalog from BigQuery to Glue Store to HMS from anywhere. Then it also have built-in transformation from SQL transformation, flat transformation, so which allow us to transform data. So let's say we are using SQL query, using the ingestion process. This builds us the functionality, simplifying data process tasks, make it easier to apply complex logical on the fly, and flexibility to do build custom transformation. So in addition to built-in transformation, we can also build our own transformation for our specific needs and requirement, provide greater control over how data is processed and ingest. Uh, Throughout the process, when we are using Hudi, we found out some limitation when we are using mostly Kafka-based source. Like it enforces the schema provided class. So we have to provide a schema. Like it can be either Avro schema files or schema registry kind of a class we have to provide and the source for it, which limits the schema evolution handling part for the Kafka. And the second is the another limitation is the absence of consumer based mechanism for ingestion for Kafka. This means that Hudi data stream, we will not able to monitor much on the part of the consumer side if you want to track easily the lags and all those stuff, which is the more that limitation for it. But despite these limitations, Hudi remains a robust and versatile tool for data ingestion, particularly when combined with Spark. Its checkpoint-based mechanism build and custom transformation and seamless data catalog significantly enhance the ability to manage and process data efficiently. So let's deep dive into how the internal working of the Hudi data streams work, and I will also provide you uh, how we overcome these limitations uh, of the Hudi data stream and what we can learn out of it. So you see in the diagram that what happens. Let's say you submit a Hudi data stream job in your Spark job. uh, First process is begin when you submit a job. It read all the configuration and properties for that particular ingestion table is specified in that particular job. So let your primary keys of Hudi stream and all those stuff it reads, and then what it does, it's create another wrapper out of it, which is called stream sync. Now earlier it was called delta sync before uh, tag 14. uh, Upon receiving the job, what happens is Hoodie's delta stream create a stream sync based on the provided properties, and then stream sync initiate a synchronized process, which can be either continuous stream or a single stream. If we have provided a parameters to continuously run one by so what it will have the Spark job will continuously run until we specify a particular condition out of it. uh, so the Steam jobs will continue to run. Mostly uh, that is the use. After identifying how it should be running, it's read the data from the source. It checks, so Hoodie the SLSIM checks if the checkpoint is present or not and retrieve the last checkpoint from the Hoodie metadata and start ingesting from that particular checkpoint. So it start reading from that checkpoint. By reading the checkpoints, it also checks whether the transformation have we provided any transformation or not. If if we have provided the transformation, so one case is that it can be a multiple chain transformation or it can be a single transformation also. So if there is a case when we have provided a transformation, what happens that Hoodie statistics team will read the source data based on the format, which includes like raw format, JSON format, or any, let's say we have provided DFS source type of a thing or a Kafka source. So it will identify what is the format of the class, and then on that base it will create a wrapper of formatter, and uh, then after creating a wrapper and formatter, it will be from the last checkpoint. Let's say from for S3 base ingestion, or it will check the last modified date. For the Kafka source, it will be checking the last offset it had read, and that is stored in the Hoodie data meta stream. Now, after moving to that, what will happen? The transformation will be applied. It can be single transformation or multiple transformation, which will be running in a sequence, how we are specified in the job. After completing all those stuff, what will happen? It will compacting. It will learn the compaction and write it into the using a Hudi common streamer, data store streamer writer, and it write into the by compacting the data. If we have enabled the compaction and all this stuff, it will write it, and then finally OD stream will sync the metadata if enabled, ensuring the metadata is associated with the ingested data is synced and up to date. So while we were using Hidi stream, we came and learned a lot of things. Few of things are like to enhance our data ingestion process, we have built our own transformations to overcome the Kafka JSON source limitation. Like we have created a source schema generator class which dynamically generates the schema for JSON source in Hudi data stream that emulate the need for separate schema provided class, enabling automatic schema creation based on incoming data. Also, we have also have a post-process transformation for even for addressing like schema evolution in the source part while reading from source. So it also adjusts the same way to process the ingestion process and automate the new changes and ensuring the seamless data ingestion. Also, we have learned out that for row-based data source, we don't have to provide any schema. It can infer schema automatically and works fine with that. uh, Third and fourth and most important thing. So Hudi streamer we can provide in a central configurations like in a Hudi either in a Spark you can define it in a EMR you can define it using Hudi config yeah, Hudi config.xml and which centralize the Hudi configurations path and simplify the maintaining and updates for us. So, by developing our own custom solutions and leveraging advanced transformation mechanism, we able to deliver these limitations with Kafka JSONs, overcome the limitation of Kafka JSONs. And now, let me deep dive into the how we are using Hudi data streams to decrease our cost. How it help us Hudi help us to decrease our cost and in ingestion processes how much it is improved for us. So first what we have done, we were using Hudi earlier like 0.10 7 or 10 version. Then we have migrated for 0.10 to 0.12.3. Now from there we have enabled the metadata also, and with the newer version we found out okay, with Athena we can simply provide one property for particular table Hudi tables like Hudi.metadata as mentioned here. And in Spark when we enable the Hudi data stream, uh, by using these functions we have simply reduced over 60% of the S3 network cost, because the list cost has been reduced for us and which is and become less and less than zero. So that's why our 60% of the reduction has happened on that part. The second thing what we done is the ingestions efficiency SLAs. So we have reduced our SLAs to 15 minutes with 2 to 5 million transaction within our average within a merge on that. We're using an index based search. Also, we have migrated from Snappy to the STD compression, which again will lead us to 30% decrease on our data size, and also the reduction in storage and also the Athena cost because Athena works on the part of how much data it reads, right? Next and the most part is that async compaction, uh, which we have greatly used in our pipelines. So it handles our the small size problem, which we can be easily set using the Parquet small file size or Parquet max file size. We have also found out that there's some page configurations also there for the Parquet size. We are trying to leverage that also. So the Hudi under Spark understream only read a particular page from a particular pipeline, particular file. It also reduce the query uh, cost for us. That's it from my side. Thank you, everyone. Uh, if you have any question, you can reach out to me. And in Zupee, we are hiring. Uh, Please do check out our LinkedIn page. We are hiring across domains and different domains. Thank you.
Thank you so much, Amarjeet. Yeah, this is a really nice and crisp presentation. Yeah, it is good to see like the transformation and the custom transformation that you have done, and kind of the agility that provides with the Hoodie Streamer, right? Uh, I'm going to check for any questions. I do see, probably one or two here, but I also let people like ask any question, post any questions on our LinkedIn page, and in the meantime, we'll be answering them. So, Somil says, any reason for choosing Debezium over DMS? Just the
Actually,
decision. Yeah.
yeah. So actually, we are using DMS, but we are thinking of transforming toward the division mostly because of open source reasons. And second thing we have seen with the DMS, we were not able to ingest. We have to ingest full data for the Mongo. We can't filter out that data. If something happen bad happen, if we want again we have to read the full data, then it is a little bit hectic for us. That's one of the reason for it.
Makes sense. All right. So, uh, I can like ask one question as well. Like, given this implementation of custom transformation that you have done, do you plan to like open source or something of this sort?
So we can. I have contributed to multiple things in the Hudi pipelines and planning to do, but it's more our use case part. I can morely transform it, more, making it more generic, or even we can transform what is currently happening in the ZSTD part. Sorry, with the Kafka source part, we can further schema. I can contribute directly over there, so we don't have to use the transformation.
Okay, makes sense. I have another question from Po, who says, after switching to ZSTD, besides storage cost saving, what about the effect on query performance? Anything worth calling out?
Yeah, so for query performance, we have seen the write time a little bit increase, but the query performance has increased, like for the Athena part, of course, and for Trino also, because the compression ratio was higher as compared to Zupee.
Right. Um, Another question. I don't know if like it's a new implementation with Hoodie in your organization, but why did you choose Hoodie over other table formats? Was there any particular reason or like any kind of decision that went toward that?
So when we have done some POC, so when we have also tried Delta Lake, but we have seen when the comes to the near time part, the ingestion with the Hudi works much better as compared to others open source platform format asset format platforms, which was the one of the main reason for us, because mostly you are working on the real time data and not on the batch side. That was the major factor for us.
Got it. Do you also think like just to add on to that, like do you also think like the Hoodie streamer being a part and utility of the Lake platform, it adds a lot of value which is very native to Hoodie versus like other ingestion jobs or like compute?
Yeah, that makes sense. Like I've seen that Woody Data Stream has lately introduced with incremental sync also. So that will be very grateful for creating a CDC like SCD, solely changing dimensions for us. We might be leveraging that in the future. Also, there are other utilities like Kafka Connects. We are also doing that POC on that. We will be working on that. If that works, we are currently using S3 Connect. Uh, Instead, we are trying to move it to Hudi, because Hudi asset properties and those compaction and all those stuff which is inbuilt in with Hudi data streams, which gives such a much. We don't have too much work on the compaction and small file size problem, which we are currently seeing with the Kafka Connect.
Got it. Perfect. I also saw like your architecture had like a real time kind of ML prediction that you were talking about, like or recommendations or whatever that is. But are and you're being serving those with like Flink ML or something like that, or and basically I'm assuming the features like are you consuming like data directly from one of the layers of like Hoodie, or is it like use a feature store for making
Uh,
those?
we, so we are directly using Kafka events, not the layers currently, and
Okay.
then we creating in real time. We are creating the features and storing in a feature store, and then also the whenever real time prediction pipeline is running, which also reads from the in a real time the feature stores when landed, the features are read it from it mostly.
All right. Cool. Thank you. That was a huge flow of questions, but I'm going to like give more time to the users to see if anyone has anything else. Mhm. Are you also looking forward to anything, any interesting work that's happening in Hoodie, the project, or like any new versions or anything that you are working on and looking forward to, apart from what you have right now?
I'm looking forward to that uh, the part with a copy of the page. I don't remember the NFC number.
Right,
It was like it will be like for the COW it will be very much faster.
right.
They are we are seeing some performance decrease with the Hoodie as we are moving to. I'm also trying to identify like we earlier in we were in Hoodie. What happened in Spark when we are ingesting, it used to cache the data, but
Hmm.
now the newer version it is not caching the data, so it's the performance is a little bit decreasing for us. That's one of the factor for us we have seen. So I'm still trying to open that, figure out what why we have changed it, and then create an issue in the and have a discussion on that one.
Perfect. One more question quickly. It says, have you experienced upgrading Hoodie in EMR? If so, are there any best practices for such upgrade?
So best practices, yeah, that's a good question. So what we have done, yeah, we have upgraded. So we don't upgrade. What we do, we just don't use the EMR a jar, which is already provided. We use our open source jars. So that way, we just have to upgrade the jars using a multi-tenant framework. So which is also controlled externally. How what jars should be going for what particular job for multi different work Spark version we can also do that. And even for particular job we want to use, let's say we are currently using 0.12.3, if we want to use latest version like 0.14.1, so we can just put the jar into a particular file in our in a YAML file, and it will be using that. So is a easy for us, very easy for us.
Right. Perfect. I'll just give more like 2, 3 minutes and see if anyone has anything else. But thank you so much for Amarjeet. Like I know it's kind of late in India. Like it's just really appreciate the time and sharing with the community. I think it's important, like to bring this kind of like important use cases that you are doing within the organization. It adds a lot of value, and also like gives an example, like for like new users to like try out things and also like see the what worked best, what didn't work out. Like it's really important. Like yeah,
Yeah, that's true.
right. All right. I think I don't see any like follow up here. And I think we have the sync mode to like take any more questions that you might have and for the viewers. And once again, thank you so much, Amarjit. This was a really insightful dive, and I think it also like opens up a lot of like avenues for more workloads and more use cases. So thank you so much for joining the community like session and sharing this with the community. And yeah, really appreciate it.
Yeah, thank you for inviting me, and I'm looking forward to more contributing to the foodie community and
Absolutely.
you guys around here.
All right. Thank you so much. Thanks, everyone. Thanks for joining this session. Yeah.